Hi, and welcome to my video on extra questions on square root radicals. These extra questions is using some of the content in the previous units that I developed, so I'm always reviewing to make sure you keep your skills going. Let's practice. Practice means pause the video, work out each of these answers first, and then press play to see if you're right. Do it for each question and see how well you're going to do. Number 1, express as a radical in simplest form. 4 subtract 3 root 3 less the product of root 3 and 2 subtract 4 root 3. So that's 4 subtract 3 root 3 less is subtract the product. Product means multiply. Root 3 times 2 minus 4 root 3. So that's a statement made, and we write it in algebraic terms, expressions. So we have to do PEMDAS first, and PEMDAS, or BEDMAS. We have to multiply. We can't, inside the brackets, P, there's no simplification in either one of these. There's no exponents, so they're down, so we can multiply and divide. So we have to multiply before we subtract. So if we want, we can multiply root 3 times 2, or we can, little tiny dilemma here, not much. I can leave the negative there and just multiply the root 3 by that, or I can go plus a negative and multiply like that. So that's negative 2 root 3 and a positive, and that's root 3 times 4 root 3. 1 times 4 is 4. Root 3 times root 3 is 3. So that gives me a positive and negative times negative positive 12. And now I have 4 subtract 3 root 3 subtract 2 root 3 plus 12. And we have to add these like terms. Gives us 16. And negative 3, negative 2 is a negative 5 root 3. Okay, number 2, show that the rectangle with sides of 5 plus root 5 and 5 minus root 5 has the same area as the square with a side of 2 root 5. So a rectangle, the area of a rectangle, I'm going to call it R, is length times width. So that makes it 5 plus root 5 times 5 minus root 5. Oops, root 5. I better write a root 5 here. That's a minus root 5. Sorry about that. And how do I know? Well, 5 plus that number is larger than 5 minus the same number. And these are, notice that these are conjugates of each other. So it's the fast way. You can do FOIL here. Fast way is 5 times 5 is 25. Subtract root 5 times root 5 is 5. So that gives us 20. So if we did the FOIL, first, outside, inside, last, on these binomials, you would still come up with the root of 20. The area of the square, we call it S, is the length of the side, which is 2 times root 5 squared. So that's 2 root 5 times 2 root 5. And 2 times 2 is 4. Root 5 times root 5 is 5. So that gives us 20. They have the same area of 20 and 20. So the area is 20 here and the area is 20 here, so they have the same area. Number 3, express as a radical in simplest form. The sum of the squares. Sum means, when we say sum, we talk about add. So the sum of the squares. So that means we have 3 root 2 being squared, the sum of their squares, and we have root 6 being squared. So that's the sum of their squares. And 3 root 2 times 3 root 2 is, I'll write it down like this. Let's write it down here. And root 6 squared is root 6 times root 6. And when we multiply this, we get 3 times 3 is 9. Root 2 times root 2 is 2, so that's 18. Root 6 squared is Root 6 times root 6 is 6 because it's the square root of 36, and that gives us a 24. So, number 4, a rectangle has a diagonal of 9 and a width of 6. Find its area as a radical in the simplest form. So let's just draw the diagram here. Now we got a rectangle, and the rectangle has 4 right angles. So it says it's diagonal. So the diagonal goes from one corner down to the other like that. I'm trying to make a straight line here. And the diagonal is 9 in length from here to here. And the width is 6, so we call that the length. And we call that the width. There we go. Find its area. But to find the area, we need the length times the width. We need the length. So to get the length, we have Pythagorean. So we have c squared equals a squared plus b squared because we got a right triangle. C is the hypotenuse, so that's a 9 squared. This is a 6, and the other side is the b. So we call this the b. We say that's the L. Okay, because that's the other unknown. So we have, that's the Pythagorean property based on the right triangle. So 9 squared is 81, 6 squared is 36, plus L squared. If we leave the L squared there, then 81 minus 36, it's easier to move. I could move the L squared over here and make a minus, move the 81 over here and make it minus, and it would still come out to be you're dividing by a negative. So L squared is equal to, and that's a 45 when we subtract it. So L is equal to the square root of 45. So let's go up here. 45 is 9 times 5. So that's a 3 square root of 5. And the area of a rectangle is length times width. So the length is 3 root 5 times the width, which is 6. And we multiply. 3 times 6 is 18. So we get 18 root 5. Notice I didn't do anything with the dimensions as in centimeters or feet or anything like that, because this would have been like centimeters and the area would have been square centimeters, but I didn't concentrate on that. What I was concentrating on was working with the radicals. Number 5, it says we have a triangle with the 3 sides given with some radicals and x's. The perimeter is 18 plus 15 root 5. Find x as a radical in simplest form. Well, the perimeter means to add up all the sides. So the perimeter is 2x plus 6. Add on 4 plus root 5. Add on 6 root 5 plus 8. So I'm adding up all the sides, and now I'm going to add up this like terms here. That's the perimeter, so I'm going to simplify this expression first. So I have a 2x, I have a 6, a 4, and an 8. So 6 and 4 is 10, and 8 is 18. And I'm going to add root 5 and 6 root 5. So 1 plus 6 is 7 root 5. So that's fully simplified. Notice it says the perimeter is, so we have the perimeter given as 18 plus 15 root 5. So that means if this is all the sides added up, that means that this expression right here must equal this one. So that means 2x plus 18 plus 7 root 5 must equal 18 plus 15 root 5. And notice you got the two expressions equal. We have 18 on each side. So I can bring the 18 over here and make it a minus. But when we're doing equations, because I'm going to bring 18 over and make it a minus, I can delete those from both sides. Just cross them out. So that means the 2x is 15 root 5 minus 7 root 5. So the x stays on the left side and the number moves over and becomes a minus. So 2x is equal to 15 minus 7 is 8 root 5. and we divide both sides by 2, so x is equal to 8 divided by 2 is 4 root 5. So that's the value of x to make this expression true. Number 6, we're adding monomial expressions, and this is a radical in the bottom, so I'm going to multiply top and bottom by root 5. 20 is 4 times 5, and this is okay. So if I simplify this one, I get 8 times root 5 is 8 root 5. Root 5 times root 5 is 5, so that is simplified. 4 times 5 is 20, so that's a 2 root 5. Subtract root 5 over 2. Now we need a common denominator because we're adding fractions. So the LCD for 5 and 2 is 10. So let's put a 10 here, and put a 10 right here, and put a 10 here. So 5 into 10 goes 2. 2 times 8, that's 16 root 5. That's over 1. So 1 into 10 goes 10. 2 times 10 is a plus. 2 times 10 is 20 root 5. 2 into 10 goes 5. 5 times root 5 is 5 root 5. Now remember, I could have multiplied this one by 2 over 2. I could have multiplied this one by 5 over 5. I could have multiplied this one by 10 over 10. And I would have got the same result. So 5 into 10 goes 2, 2 times the numerator. 1 into 10 goes 10, 10 times the numerator. 2 into 10 goes 5, 5 times the numerator. Just another way. 2 ways to do your choice. 10 is the common denominator, so we simplify. 16 and 20 is 36. Minus 5 is 31 root 5 as the final answer. You cannot cancel an irrational number with a rational number. Cannot cancel root 5 into 10. Number 7, if we think about it, we're going to do PEMDAS, P-E-M-D-A-S, or BEDMAS, whatever you want. BED, B-E-D-M-A-S is your choice, which way you learned it. But parentheses or brackets is the same. Other than that, we're okay. So we have to, there's root 10 is simplified, root 2 and root 5 are simplified, so we have no brackets, no exponents. We have no exponents, and we have to do the multiplication and division from left to right. So let's multiply these two first. The 5's cancel, so I get a root 10 over 3. Plus, I have to divide next. So that's a root 5 over 4 times the reciprocal. When you divide, you multiply reciprocal, so that's 2 over root 2. Now I have to just still, even though I did this division first, I have to complete this because the multiplication is done here, so that's root 10 over 3. And 2 into 2 goes once, 2 into 4 goes 2, so that's a root 5 over 2 root 2. This is still not simplified, so that's a root 10 over 3. Add on. I multiply by root 2 over root 2. The conjugate of root 2 is root 2. Root 5 times root 2 is root 10. And that's a 2 times 1, which is a 2. Root 2 times root 2 is a 2, so that gives me a 4 on the bottom. Common denominator for these two fractions, LCD, is 12. So I can do it 2 ways. Let's go 2 ways and show you. Don't make it your choice. 3 into 12 goes 4. 4 times root 10 is 4 root 10. 4 into 12 goes 3. 3 times root 10, 3 root 10. Or, if your LCD is 12, you can multiply this fraction by a 4 over 4. You can multiply this fraction by 3 over 3. 3 times 4 is 12. 4 times root 10. 4 times 3 is 12. Root 10 times 3. And you get the same answer, but I just wanted to show you. 12 is the common denominator, and you add up the numerators. So that's a 7 root 10. And you can't simplify. You can't simplify the root 10 and 12. So 7 is not a factor of 12, so that's the final answer. Let's continue. Number 8, find the reciprocal of the sum of these two. The reciprocal means is 1 over. So the sum means add. So the sum is 3 plus root 5. And so the reciprocal of the sum is 1 over 3 plus root 5. So the sum means add, and you get the reciprocal as 1 over. So to simplify that, we multiply by the conjugate of 3 minus root 5 on top and bottom. And that gives us 1 times 3 minus root 5 is 3 minus root 5. And because these are conjugates, a short way is 3 times 3 is 9, minus root 5 times root 5 is 5. And that gives us 3 minus root 5 over 4. Now, I did the fast way because they're conjugates. I multiply these two, multiply these two. You could have done the FOIL on this, and you would have ended up with this because the 3 times root 5 would have given you negative 3 root 5. This would have given you positive 3 root 5, and they would have canceled out. So you could do FOIL or I call it the fast way. Nice to know the fast way. Now we have an extra question here. I call it extra, but it's not an extra question. It's just extra something to do or think. Solve for x as a radical in the simplest form. Now, this is not done too often. Again, the video I did on solving with radicals is, again, to review your skills. Practice. So we have to eliminate the brackets first, as we would. So we multiply 3 by root 5x, 3 root 5x. 3 times negative 1, 2 times this bracket, 2 times x, 2x, 2 times root 5x is 2 root 5x, plus 1. So I remove the brackets. Now I have to, can I add any of these together? No. Can I add, see, 5x and 3 root 5x are not the same. These are not, you can't add these. They're x's, but you can't add them. You can't add these. So what you have to do is that you have to group your x's. So I got a 5x, add on 2x, and I have a 3 root 5x, add on, or sorry, subtract. We got to be careful. This one is coming over. Oh, and I brought this one over. Oh my, got to be careful. I'm thinking more than working it out. So 5x, bring this one over, it becomes a negative. This one is already here. I bring this one over, it becomes a minus. So that's a 2 root 5x. I have a 1 and plus 3. Numbers go on the right, x is going left. Notice I kept these two together because they're like terms, and these are like terms. So 5x subtract 2x is 3x. And when I add these, I get 3 subtract 2 is 1, so I get a 1 root 5x equals 4. And you notice I still can't, this is why I call it an extra. It's a bonus question. You can't add these because they're not like terms, so you have to factor out the x. So this is 3 plus root 5. You could put an x in the front or put an x here. I'm factoring out the x, because you can't add these. So the only way you can solve this is to factor out the x, because the x is the GCF. Now I'm going to divide both sides by 3 plus root 5. They cancel, they give me x. And I had to simplify this. So this is a fraction. So the conjugate of 3 plus root 5 is 3 minus root 5. And I do that on top and bottom. So 4 times 3 is 12. 4 times negative root 5, negative 4 root 5. And again, we have two numbers that are conjugates of binomials. So 3 times 3 is 9, minus root 5 times root 5 is 5. So that gives me 12 minus 4 root 5. You can't add them because they're on like terms. And 9 minus 5 is 4. And as it happens, 4 will divide into both of these. So if you think about it, there's 12 over 4. Subtract 4 root 5 over 4. You can write it down like that, which ends up to be 12 divided by 4 is 3. And 4 divided by 4 is root 5. Really, you're putting the 4 below both of these and dividing it into it. Again, as a bonus question, and you met this in one of my videos, factoring. Keep reviewing, and things will happen. Keep practicing. Number 10, 3 plus root 2 and 3 minus root 2 are the blank of each other. And remember, you're pausing the video and you're working them out, and you say that they're the conjugates, you would be right. They're the conjugates of each other. Find their products by the short method. Well, the short method, I'll show you the short method. The short method is, because they're conjugate, is 3 squared minus root 2 squared. So 3 times 3 squared is a 9, minus root 2 times root 2 is 2. That's the short method. But let me show you the long, not the long, well, it's longer. The long way is to multiply. So the long way would be to multiply them out by FOIL. First, 3 times 3. Outside, negative 3 root 3. Inside, positive 3 root 3. And last is a negative 2. And they cancel out. That gives you the 7. So this is the fast way. But the FOIL is just as quick. But this is good to know too. Okay, number 11. Square 4 minus root 7 by using the pattern. So we're going to square all this. So some people could read this. Just think. The square of 4 minus. So this, you could interpret this as the square as 4 squared minus root 7, which would have been 16 minus root 7. To square this by using this pattern. So I need to put a bracket around this to make sure you're going to square all of this. By using this pattern, the pattern is, if you have an a minus b squared, that's an a minus b times a minus b. And the pattern, if you have it, is a squared 2ab b squared. There's a minus and then that's a plus because that's a minus there. So the pattern would be that if you have that, that's 4 minus root 7. That's the a and that's the b. So if you think about it, a is 4. B is root 7. So I wrote down the pattern, and now I'm working it out. So that's a 16 minus 8 root 7. Root 7 squared is 7, and 16 and 7 is 23 minus 8 root 7. Again, the other way when you square that is to write it down twice, like this, which is nothing wrong with that either. But sometimes teachers will ask you to memorize the pattern, and sometimes it'll help in the future. Not sometimes, it will help in the future. So you can do the FOIL on this and you'll still come up with the same answer. But this is the pattern when you square. Okay, let's continue. Number 12, remember, pause the video and work them out first. Work each one. Find the surface area of a cube if its sides are root 18. Now remember, a cube is a box that's made up of like this. So here's the box. And a cube has, as you can see, a cube has 6 sides, 6 faces. So it's 6 faces. And each face is a square. So each side is a square. So the surface area is the area of a square. The area of a square is s squared then the area of the cube, or the surface area of the cube, is 6 times that area. So the side of the square is root 18. So we take the root 18, put it in, but if you want the root of 18, 18 is 9 times 2, so 18 is 3 root 2 squared. So that's a 6, so that's 3 root 2 times 3 root 2. Let's multiply the radicals first. 3 times 3 is 9. Root 2 times root 2 is 2, so that's an 18. And 6 times 18 is 108. Now, even though I changed that radical, I didn't, to work it like this. But what about if you did right from here? What about if you said, watch this, if you said 6 and it's the root of 18 squared? Well, I went through all this, but when you take a radical and square it, what do you get? You get the number underneath your radical. If you took root 5 and squared it, it'd be root 5 times root 5 is 5. Root 7 squared is root 7 times root 7 is 7. So root 18 squared is 18. So you could have got there much faster if you said root 18 times root 18 is just 18. But I went through root 18 is 3 root 2, multiplied it by 3 root 2 times 3 root 2 to get the 18. You could have went just this way. Anyway, the surface area is, again, if this is in meters, it would be square meters. The area is 2 dimensions. And number 13, find the volume of a rectangular pyramid as a radical in simplest form if the base is root 15 by root 5 and the height is root 6. So what we have is a pyramid, rectangular pyramid like this, and the base is root 15 by root 5, and the height coming down from the top to the bottom is root 6. So the volume of a prism, we're doing the volume, so because it's a pyramid, it's going to be 1/3 the area of the rectangular prism. So it's 1/3 base area times height. So the volume is always the base area times the height. But the base of this pyramid is a rectangle, so that's length times width times height. And it's a 1/3, so it's 1/3, and the length, you could take it as root 15. The width is the root 5, and the height is root 6. Now, if you multiply them numbers out, you're going to get a big number. Then you're going to have to break it down. So here's what I would do. I would take all them and multiply them all underneath 1. Just watch. Go 15 times 5 times 6. And then I still wouldn't multiply them. I would break them all down. 15 is a 3 times 5. The 5 is a 5. And the 6 is a 2 times 3. Now, what I do is I start picking out the pairs. So I got a 3 here and a 3 here. That's 2 3s. So I would take a 3 out. I got a 5 here and here. So I take a 5 out. And there's only 1 2 left, so that stays. So 1/3 times 3 cancels. They're 1s. So I get a 5 root 2 as the volume. And again, the volume is in cubic centimeters, cubic feet, cubic yards, cubic meters, whatever. But I'm not concentrating on the dimensions because I know it's the volume is a cube. But I'm concentrating on why multiply all that. Like that's if you think about it, that's a 75 times 6, and that's 40. That's 450. So if you did that, you would have got the square root of 450. You would have to break the 450 down by multiplying by 10. But if you write the numbers like this and break each of those numbers down, you pick out for every 2 you take 1 out, because 3 times 3 is a 9, the square root of 9 is 3. 5 times 5 is 25, so the square root of 25 is 5. So this is easier than doing it You can do it this way, but I think it's simpler this way. That brings us to the end of the extra questions review, just reviewing skills or concepts that you learned earlier. And if you like my video, click the like button, click the subscribe button, click the notification bell, because there are more videos coming your way. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel. Thank you for viewing my video. That brings us to the end of this unit on radicals. Bye-bye.